looking at 3D problems. So the main thing we need to remember when we're doing 3D problems is to identify the triangles. Okay, so kind of what's highlighted there. So we identify the triangles, then from that we can kind of figure out where we need to go. So once we've identified and then sketched as well, we're able to decide which of our four tools. So our four tools are our Pythagoras, our trig ratios, our sine rule, and our cosine rule. Those are what we would consider maybe our four tools that we can use in answering these questions, because they're kind of our four triangle tools. Now, note as well that you'll be mostly looking for right angle triangles. So the key steps are identify the triangles, sketch the relevant triangles with all the info that we have, highlight what we're looking for, and then decide which tool is most appropriate. And noting that you might need a combination of tools. So maybe Pythagoras might be needed to start the question, but you may need to continue with cosine or continue with sine rule. So looking at this question here, we have a cube that has sides 5 centimeters, and we're looking to find the measure of this angle here. So if we sketch out the triangle that we're kind of looking about, so AHD, and we want this angle here, theta, okay, so we want this angle here. We know that AH is 5 centimeters because it's a side of the cube. So if we could find this side here, HD, then we could use that in solving the whole triangle. Okay, we could use a trig ratio. So if we were to look at this smaller triangle, or not smaller, but just alternative triangle, HED, okay, so marked in where I have the orange there. If we look at this triangle now, well, this triangle is on the base of the cube, so we know that it has a square base, which means that the corner there at E is going to be a right angle. I know that each of these sides is 5 because it's a cube, and I'm looking at the base of the cube, and I was told that each side is 5 centimeters. So if I use Pythagoras' theorem, I could find out what HD is. So HD squared is 5 squared plus 5 squared. So HD squared is equal to 50 altogether. So HD is the square root of 50, which is 5 root 2. Okay, then using that in my question, I can get tan of theta, tan of theta is equal to, so HD, or AH, over HD. If we look at the triangle, we can see that my opposite side is AH, and my adjacent side is HD. So tan theta is 5 over 5 root 2, which makes theta equal to the tan inverse of that. So tan inverse of, again, the same thing again. So theta is equal to, if I take the tan inverse of 5 over 5 root 2, I get 35.26 degrees as my answer. Okay, so that's my overall answer. If we look then at an exam question, so a glass roof lantern in the shape of a pyramid has a rectangular base. So let's highlight the key points here. So rectangular base, its apex is at B, the vertical height is AB, and CD is 2.5, and CF is 3. So we can see some of these points are already highlighted. We have our apex point at B. The first thing we're looking for is to show that AC is 1.95 meters. So let's kind of work out where AC is first. So AC is along here. Okay, so we want to prove that this length here is 1.95 meters. Okay, so there's a few different ways that we can approach this one. What we could do is look at the rectangle. So let's just take this out, the base of the pyramid, the rectangular base. What we should know about a rectangle is that the diagonals of a rectangle bisect each other. Okay, so bisect each other. So what that means is that this length is equal to this length, and this length is equal to this length. Okay, so these four lengths are all equal to each other. And what that means for us is that if we look at the full length, this full length here is equal to, so, and then if I'm looking for the length here, which was CA, CA is going to be half of CE. Okay, CA is half of CE. So if I can find out what CE is, I can then find out what CA or AC is. We know that this is 2.5 and we know that this is 3 from the question. So taking that triangle then, if I was to draw that out, CED is 2.5 and 3. We know this is a right angle because it's a right angle triangle. So AC squared is 2.5 squared plus 3 squared. 2.5 squared is 6.25 plus 9. So EC squared is 15.25, which makes EC the square root of that, which gives me around about, let's say, root 61 over 2. Okay, so I'm not even going to give my decimal at this point yet, because what I'm looking for is half of EC. So we've said that AC is half of that, which is a half of root 61 over 2, which of course is root 61 over 4. And as a decimal, we get an answer of approximately 1.95 centimeters, which is exactly what we were hoping to prove that it would be. So we've shown that that is the correct answer. The second part asks us to find the angle of elevation of B from C is 50 degrees. Okay, so first, well, that's just told us the angle of elevation of B from C is 50 degrees. So where is that? We can mark it in. That's over here. Okay, so that's at this point here. Show that AB is equal to 2.3 meters. So show that AB is equal to 2.3 meters. Well, let's find AB on my diagram. AB is this point here. Okay, so in terms of the information that I have, if we draw out our triangle, so we'll do the triangle that involves all the sides that we have, or all the sides that we're looking for. So we'd be up here, A and C. We know that AC is 1.95, and we know that this angle is 50. And we want to find the green side, which was our AB here. So we can use our trig ratios. So tan of 50 is AB over 1.95. So AB is 1.95 tan 50. And continuing on, we can just get our answer for that one. And we get an answer of 2.32. And to one decimal place, that's going to round to 2.3 meters, which is, of course, the answer that we were asked to show. So again, these questions where you have to show the answer are always kind of nice ones, because you can see where you're trying to get to, and you can kind of be happy enough that you're correct. So looking at part 3, find BC correct to the nearest meter. BC correct to the nearest meter. So let's have a look. So same triangle again. Okay, we're sticking with this triangle. We have this as 1.95, we have this as 2.3, and we should know that this is a right angle, because looking at our diagram, we're told that A is directly underneath the apex of the pyramid. Okay, so the apex is the kind of the high point of the pyramid, and that's going to be directly over the kind of middle point where the diagonals intersect on the curve at the bottom. So it's important that we kind of recognize that that will be a right angle. Because it is a right angle, it means that we can use Pythagoras' theorem. So 2.3 squared plus 1.95 squared. And we continue on as normal, as we've done. Kind of seeing here with all of these questions that what we're ending up with each time is essentially another right angled triangle question. Every single time we're kind of just ending up with the same thing to look at. It's important just that you have all of those tools at your disposal, that you're definitely confident with using each of the tools. So your Pythagoras, your trig ratios, all of those. So 3.015 meters, and we were asked just to find it correct to the nearest meter. So to the nearest meter, that's going to be 3 meters. It's the nearest meter. The next part then asks us to find the angle BCD. BCD correct to the nearest degree. So let's kind of construct that triangle. So we can see it here as this one here. Okay, and we do have a lot of the information relating to this one. So if we kind of look at the information as we have it. So let's draw our sketch. Okay, so this is B, this is C, this is D. What we want to find is this angle here. Okay, BCD, so we can call it theta. We have BC from the previous part. We should know that that will be equal to the other angle as well, or the other side as well. So those two sides, BC and BD, will be equal as with the far sides. Okay, so following on, then we know that CD is 2.5 meters. So looking at what we have at our disposal, we have three sides and we're looking for an angle. So the best thing for us to use here would be the cosine rule. Okay, because we have three sides and we're looking for an angle. So when we have all three sides, we'll use our cosine rule. So a squared is b squared plus c squared minus 2bc cos a. Okay, so taking a squared as the 3 squared, b squared can be also 3, and c squared is 2.5. Cos theta. Okay, so I'm taking this as being my angle A, if you like, and this being my side A. I'll take this as B and this is C, is the way we're going with it. So this gives me 9 is equal to 9 plus 2.5 squared is 6.25 minus 15 cos theta. So I get then that 15 cos theta is equal to 6.25. So cos theta is equal to 0.25 divided by 15, which gives me 5/12. So my answer for theta then is the cos inverse of that, which gives me 65.376 degrees, and we're asked to give our answer to the nearest degree. So to the nearest degree, theta is 65 degrees. To the nearest degree. Okay, so we're slowly kind of getting through all the parts of the question. The last part then, part 5, says find the area of glass required to glaze all 4 triangular sides of the pyramid. Give your answer correct to the nearest meter squared. So find the area of glass required to glaze all 4 triangular sides of the pyramid. Okay, so what we know is we have one triangle BCD here, which has a side length of 2.5 for CD, for the edge here. On the far side, we have another triangle which would have the same measurements completely. Okay, we've already decided that this side and this side have the same angle, or have the same length, and it's to do with, I suppose, the triangles that we have, and also the way that we came to those answers, because every other measurement, this measurement is the same as this measurement, as we said at the start, and the middle measurement would be the same as well. So we end up with the same measurements following us through the whole way. So continuing on then, we look at the other 2 triangles that I have. So the other 2 triangles that I have are going to be these 2 on the side here. Okay, so BED and BFC. The only slight difference with those is the angle 3 meters that we have. Okay, the angle 3 meters. So instead of us having the other angle, we now have a different angle to work with. So if we look now at all this information, so taking all of this into account, the first thing that we need to do is we need to make a note of the second triangle. So let's just do that down here. Okay, so I'll just go back and see BFC. If we take BFC, so in terms of my sides here, both of those still 3 meters. Okay, what changes is we have 3 meters here as well. What we should see now is that if I have a triangle where the 3 sides are all the same, then what we have is an equilateral triangle. An equilateral triangle. And what we should know about an equilateral triangle is that the three angles are all the same and they're all 60 degrees. Okay, so an equilateral triangle, all sides are the same, all angles are the same. And that just saves some time for us, really. So it gives us one of the angles without us having to work it out. But if we worked it out, we'd be able to get to the same answer again. But what this means now is we can use this in finding the area. So if I focus first of all on this triangle, so the area of BFC is half AB sine C, so a half of two sides and the angle between them. Okay, so taking two sides and the angle between them. So 3 by 3 sine 60. Okay, so we can put that into our calculator then to work out our answer. And we get a value of 9 root 3 over 4. 9 root 3 over 4. If we look then at the area of the other triangle, which was the one up here, BCD, again, half AB sine C, so half of two sides and the angle between them. We'll use the two sides we have there, so 3 and 2.5 and the angle 65. So a half of 3, 2.5 and sine of 65, and we get an answer of 3.39865. So let's leave in a few decimal points. So the total area of glass required is 2 of the first triangle and 2 of the second triangle. Okay, so 2 of the first triangle, 2 of the second triangle. So matching them up with the 2 that we had there, that was the first triangle. So 2 of those, and then 2 of the second triangle, which was the kind of lighter pink in my original diagram. So we said that we need the two sides that are opposite each other in the pink and the two sides then that are opposite each other in kind of the dark blue part. So adding those up, working out those answers. So here I get 9 root 3 over 2 plus 6.7973, and adding those together, I get an answer of 14.59 meters squared. And we're asked to the nearest meter squared, which is, of course, 15 meters squared is my answer. So in doing that question out, what we're seeing is that we need to be able to quickly move between each of our rules and identify which of our rules works best for the question, but also that we just need to continue kind of following through with the question. So just because we've seen that sort of question, then the next 3D question that you see might be slightly different. So the important thing is to draw out the triangles at each step, identify what you're looking for, and use your tools from there. So we saw that we were using Pythagoras quite a lot, we were using our trig ratios quite a lot. Cosine would only come in at the end, and area of the triangle came in at the end as well. So making sure that you're really comfortable using all of those rules is going to be really important for any of the 3D problems.